The sequence over here that we have put on the board is 2, 7, 12, 17, 22, and 27, and so on. The sequence over here, we have a common difference of 5. I mean, the two adjacent number, if we subtract, the difference what we get should be equal to all the sequence number. Here we can find that it is the common difference is 5, which is denoted by the word D. D as 5. Now, the overall, when you look into it, I have put up a position and term for the above sequence. The position is, at what position is that sequence term is been put in. So the positions are 1, 2, 3, 4, 5, 6, and the term related terms is 2, 7, 12, 17, 20, 22, and 27. Now what we are trying to do is we are trying to find out that in case if I divide, or so if I subtract any number, any term with another term, am I going to get the common difference, or are we going to get a difference which are some multiples, or it's an addition of some of the common difference? Now here, let's take as 12 minus 2. The 12 stands in the third position, and the 2 stands in the position 1. So 12 minus 2 is 10. So if I look into it, it is the third position and the first position. If I minus, that is 3 minus 1, I get 2. 2 into the common difference. 2 into the common difference of 5. So here the difference what I got is 10. So there's a correlated equation which has been created. That is 12 minus 2 is equal to 10 is equals to 3 minus 1 into D, or the common difference. So the 3 minus 1 is 2. 2 into D is 10. So on both the sides, the answer is good at 10. Let's try something else again. Let's say 17 and 2. Now 17 minus 2 is 15. The position for 17 is 4, the fourth position. And 2, as we already know, it's 1. So 4 minus 1 is 3. 3 into the common difference of 5 is 15. So we have an equation over here, 12 minus 17 minus 2 is equals to 15. And on the right hand side, we have 4 minus 1 into D. And 4 minus 1 is 3. 3 into D, 5. 3 into 5 is 15. So both the sides are equal again. Let's take one more example over here. Let's take it as 27 minus 7. Now 27 minus 7, the difference is 20. Whereas 27 is the position of 5. 5 minus 2. So 7 stands in the position number 2. Here I minus 5 minus 2. Oh, sorry, 6 minus 2. 27 is in the sixth position, and 2 is in the 7 is in the position number 2, right? So it is 6 minus 2 is equals to 4, and 4 into 5 is 20. So on both the side, we're getting a rightful answer. And we keep on doing it, and we get that an answer which is equal to the D. But D is multiple of a number. That means it's a product of a particular number, or it is a multiples of 5. So here we find that the common difference for the first line we got is 10. Then what we got is 15. Then we got 20, and then we got another 20, and then we got a 3 5 15. So another 15. So here if this 10, 15, 20, 20, and 15, if I look into it, I can find out that it's multiples of 5. Because 5 2 are 10, 5 3, 5 4 are 20, 5 3 are 15, and again 5 3 are 15. So that's where we're getting multiples. So 5 is common. The multiples keep changing depending on what position we are. So in short, we get a one-line equation, and that is 12 minus 2 is equals to 12 minus 2 is equals to 3 minus 1 into D. That's the first numerical formula we get where both are equal. Both the left hand side and the right side is equal. 12 minus 2 is equals to 3 minus 2 into D. Right? This is the first formula we are getting it. But this is not an algebraic formula, it's an equation formula. Now, all that we need to do is I convert this into the term as x. Term as x. So when I convert my term as x, I get the first term as x1, that is 2 becomes x1. The 7 becomes x2. The 12 becomes x3. The 17 becomes x4. The 22 becomes x5, and 27 becomes x6, and so on. Now, if I take this as an equation, that is, if I do the same thing, but instead of 12 and 7, I put it as x2 minus so x3 minus x1. The 12 is in the third position, so there is x3 minus x1 is equals to 3 minus 1 into D. Now here, x3 minus 1, that is, am I right? Yeah, x3 minus 1. So here what I get is x3 is denoted as 12, x1 is 2. Right? So when I put the value of x3 and put the value of x1 subtracted, I get a difference of 10. Right? Now that when I look into it, what I'm doing is the third position, x3 is the third position, the 3 minus 1, the 3 and the 1, the two positions I minus, the 3 minus 1 is 2 into D. And the common difference of D becomes 5. So that becomes 2 into 5, which is equals to 10. So both the position gets equally there. Now, so in short, the first formula for the algebraic sequence, what we get is x. And the first formula that we get over here is x, 3x minus x1 or x3 minus x1 is equals to 3 minus 1 to D. Now, instead of 3 and 1 and all those things, let's put, if I don't know what the value of x, let us put xn minus or xn minus xm as two probability where I have no answer, where I do not know what the value of it. Then I put as n and m. So that becomes xn minus xm is equals to n minus m into D. So that's my first formula for algebraic sequences, where I don't have the value of my m or n or the n and m. Only I know is a position. So what I do is xn minus xm. xn minus xm is equals to n minus m into D. N minus m into D. And when I read this replace as a formula for an algebraic expression. But with this formula, what I need to find out is my D. That's common difference between the terms, the difference. So let me get a simple formula. I just need to rearrange the formula number 1 which I got it. How do I rearrange it? And your formula, the first is xn minus xm is equals to n minus m into D. Now D, I need to separate my D out from this formula. So when I separate the D from my formula, it becomes D is equals to xn minus xm divided by n minus m. So that becomes my second formula where I can find out the D. That is the common difference. Now here, it doesn't mean that I need to get the adjacent numbers or the adjacent sequence number. It could be any number within the sequence. Any number within the sequence, I subtract and divide by the position number. The position number would be whatever the position number to that, and that position I divided, I get my common difference. So this is the second formula that which you need to understand. Okay, and the third one is I need to find out what is xn. How do I get my xn? How do I find my xn in this? To find out xn, all I need to do is xn. All I need to do is I need to find out. I need to separate my xn from the above formula. Formula, that is what we found, the first one. And what is the first formula we got in is xn minus xm is equals to n minus m into d, right? Xn minus xm is equals to n minus m is equals into d. Now this formula, if I again rearrange myself, and instead of xm, I put as x1. Instead of xm, I put as x1. Or even we work with m, it hardly matters. It's the same thing. But just to make ourselves more sure about the first term, because normally a question comes with the first term of the formula, or what the second term of the formula. So to get the first term, what I do is instead of writing there as xn minus xm, what I do is xn minus x1. I replace xm to x1. So the same thing is repeated. Xn minus x1 is equals to n minus 1 into d. N minus 1 into d. But that is now replace xm as x1. Right? Now, if you go to the slide, you can understand when I replace xm minus xm as x1, what I get is xn minus x1 is equals to n minus 1 into d. And to find out xn, I need to separate xn from the above. So what I do is xn is equals to x1 plus, because when I shift my x1 from the left hand side to right hand side, the minus x1 becomes a plus x1. So x1 plus n minus 1 into d. Xn is equals to x1 plus n minus 1 into d. That's my third formula. The same thing can also be done as if I put as xn is equals to xm plus n minus m. So instead of 1, it will be n minus 1 into d. So it's not necessary that we need to find the first, the first term. But since the first term, to find the first term and to find a term, it's good enough to convert xm as 1 and then find out, so that both the formulas are equivalent to us. That is, xn is equals to xn minus xm is equals to n minus m1 into d. Here, to find xn is put out the xn outside to the left side and put the xm into the right. So that minus xm becomes plus xm. So xm plus n minus 1, n minus m into d. Here, the 1 will again get replaced by m and becomes n minus m by d. So so to find out an xn, that is the nth number, the nth term of the equation, the nth equation, the term of the sequence. To find that, the formula for us is xn is equals to x1 plus n minus 1 into d, or xn is equals to xm plus xm means the next whatever frequency sequence number we have got, that one xm plus n minus m, the position number of n minus m into d. So that gives you the figure of xn. How do we get xn? Is xn is equals to xm plus n minus m into d, or xn is equals to x1 plus n minus 1 into d. Now all that we're replacing the 1 with m, and we're changing the formula. This is subject to when I have my x1, or if I don't have my x1, then any other sequence number that is there in the sequence, we will take that as it and that position and fill up the formula to find out the answer of xn. Okay. The same way, if I need to find out x1, then what I do is I put my x1 on the left side and put everything on the right side. So here again the formula will become x1 is equals to xn minus n minus d, because here xn was plus. When I turn him to the right side, that xn becomes minus. So xn minus n minus 1 into d. So all that we did is we just shifted that plus and minus sign, and we shift that n to the right and x1 to the left. So x1 is equals to xn minus n minus 1 into d. So we have now 4 formulas in our hand. All the 4 formulas are good enough for the sequence questions in the focus area. So you need to know all these 4 formulas. And the 5th formula is to find out the n, the nth position, not the number, but the nth position of the term. Now to find that n, what we need to do is we have to shift that n minus 1 in the bracket. What we have n, we need to remove him from there and find out what is n. So now when I do that, I come back over here is x minus 1 equals to n minus n minus d, n minus 1 into d. Now that over there it becomes xn minus x1, xn minus x1 is upon d is equals to n minus 1. Now here what I did is n minus 1 into d, which is multiplied by d, n minus 1 was multiplied by d. That d, I brought him down to my left side. So it becomes xn minus x1 divided by d is equals to n minus 1. Now what I need to do is that remove that minus 1 from the n and bring him to the left and put the n to the right so that I get the value of n. So in short, my formula becomes xn minus x1 divided by d plus 1 is equals to n. Now that becomes the 5th formula. Now all these 5 formulas are very important as far as sequence are concerned, because in the focus area you are going to get all these five formulas to be used in different formulas in different ways, so that you can find the value of the sequence or the value of the per term or value of the position, and that gives you an answer. Now here, since the sequence has been given more importance, that the whole chapter has been there except from the page 7 to 15 has been eradicated from the focus area. So we need to concentrate, because we knew that from the sequence there's about 15 to 20 marks problems have been issued for the final examination. To get that 15 to 20 marks, this 5 formula is must for us. We need to by heart this formula. How do you do it? Is now you have to find out, getting the first formula, and from the first formula we keep on converting to find the 5th formula. The next 4 formulas was on the base of the first formula. You need to keep doing that, keep doing it and keep doing it, so that, and keep practicing on it, so that we can be able to achieve the best out of it. Right now, what I wish to do is, I wanted to now go into this exercise in your textbook. That is on the page number 19. Page number 19, and of all that, given example of some that which are very, very, very common, which you all can do it without even my help. You all can do it on your own by keeping the above formula or doing it in a rational way. You can find out the answer. The rational way means just you calculate the difference. പത്തങ്ങത്ത് കൂട്ടി അല്ലെങ്കിൽ റൈറ്റിൽ 10 കൂട്ടി അല്ലെങ്കിൽ 10 ലെഫ്റ്റിലേക്ക് മൈനസ് ചെയ്തു. ഇത് രണ്ടും വെച്ചിട്ട് നിങ്ങൾക്ക് സീക്വൻസ് നമ്പർ കണ്ടുപിടിക്കാൻ പറ്റും. So that's a very easy, you can do it in a rational way. But the question number 5 and question number 6 needs a little technical guidance. The question number 5 and question number 6 we will solve over here in this class, so that you will know how to handle such questions if ever you have it in your system, right? In your questions. Now that is one thing. Let's read what question number 5 is asking for. There's an angle, and for the angle, there are a few perpendicular lines. The 1, 2, 3, 4 perpendicular lines, and this perpendicular line, the only measurement that you got on this particular figure is that these perpendicular lines are equally spaced. That's all that you have. Rest, there's nothing in the total question, but you need to find out the sequence. You need to find out the sequence of it. Now what is the sequence of it? Is in this picture, the perpendiculars to the bottom line are equally spaced between them. Prove that the length of each perpendicular forms an arithmetic sequence. Now, we need to concentrate on the length of the perpendicular line only. He is not asking for anything else. What he's asking is, you need to have a perpendicular line, or the perpendicular line which is given over there, is an arithmetic sequence. Now, how do we find out? What we have got is an angle. The measurement of angle is not there. We don't need it. What we need is the measurement of the perpendicular line. What is the length of the perpendicular line? There are 4 or 5, and what he said is it keeps on growing. You can have as many perpendicular lines you want it, but all of them has to be equally spaced. Now, when I'm doing that, now we need to concentrate on the perpendicular line. So if I put that perpendicular line measurement as x, the first perpendicular line, if I put that measurement as x, what do I get? My line 1, or the line perpendicular line 1, I get my measurement as x, right? Now, if I get that measurement of x, then all other 4 or 5 or 6 perpendicular lines to the line measured x will be measured as x, right? So that there will be a straight line drawn from the point, and you get all of them as x. As line 1, line 2, or the perpendicular 1, perpendicular 2, perpendicular 3, perpendicular 4, all up to the x level can be measured as x, right? Now, the second perpendicular, if I take the measurement above the x of the perpendicular line to the top, I'll call it as y. So my second perpendicular measurement is x plus y, right? Because x is already there, and all that is there, we have added we added little more in the perpendicular line, which I'm terming it as y. So my total measurement of that perpendicular becomes x plus y, right? Now here, let's look at it. The space are equal. The perpendicular lines are spaced equal, right? Plus the hypotenuse. Now, okay, if I take the third perpendicular also, I'll have one line up to the line x is x. Then I draw another straight line, and I find that the distance between the y of the third perpendicular also can be termed as y, and above that one will be by another y difference, because all of them are spaced equally. So the difference between the first perpendicular line and the second perpendicular line, say it is y. In my third perpendicular line, I'll have one y and one more y. That means I'll have two y over there, because the y as measured for the second perpendicular line, the third perpendicular line, I'll have one y, two y. So that means my measurement of my third perpendicular line becomes x plus 2y, right? Now, when I'm having x plus 2y, there are two triangles created in this. Two triangles. That is A, B, C, and C, D, E, whatever you can carry out. Now, when you look into that two angle, the measurement of the hypotenuse side, will be equal, because the distance between first perpendicular and the second perpendicular line, or the second perpendicular and the third perpendicular line, all are same. So my hypotenuse should be same. The baseline of the other triangle will also be same between the two triangles. So what happened? This is a equilateral triangle, a congruent equilateral triangle. That means all three sides are equivalent or are matching to each other, because my third side is y, and that is also y, but only to this y. So that means that my sides are equal. So it's equilateral congruent triangle. So when in that case, my y can just becomes x plus y and y plus 1, x y 2. So here my third line becomes x plus 2y. The third perpendicular line becomes x plus 2y. Now, the reason for this is because the two triangles formed over there are equilaterally congruent triangles because the angles are matching. Everything is matching. They got one angle of 90 degrees. The second angle, that is the crossing through the hypotenuse from the side to the other one, to the other triangle, will also be the same because both angles are congruent triangles. Now, when this congruent triangle, we take it, then all the three sides, three angles also will be equal. Now, in that case, it becomes my measurement is equal to each other. The sides measured are equal because this y and y1 is the same. Y and y1 will be having the same measure. Okay. And now the fourth perpendicular, the same thing. The y1 and the y2, or the y from the first triangle, the second triangle, the third triangle, the y1 and the y2. That on the sides where I measured as y, and on the second triangle I measured as y1, and the third side I measured as y2. So all this y1 and y2 are equal as per the equilateral congruent triangle norm. All three are equal. Hence, what we get a sequence of measurement as x plus 1, x plus 2y, and x plus 3y. Right? And what's the common difference in this? Is the y. The y is the common difference in x. If you see, if I minus xy minus x, I get y as the difference. If I minus x 2y minus x plus y1, that is x plus 2y minus x plus y1. Here also I'm cutting a difference of y because of the 2y minus 1y is the term. 1y is y and x is 1. So x, the difference is y. Or if I take the third one, the same thing, I'm getting common difference of y. So having a same common difference in the sequence number of x, x plus y, x plus 2y, and x plus 3y, it is an sequence, an arithmetic sequence. This is how you need to prove this particular sum, right? If you get such sums on your question board, all you need to do, though we have nothing in our hand, we just had the measurement between the two perpendicular lines are equally spaced. That's all what you had. Now that equally spaced line is where we are getting it as x plus y, x plus 2y, and x plus 3y, which are sequence. The third one, the next question to you is, well, the next question, the sixth one. What he says is the algebraic expression of a sequence is xn. Algebraic sequence of an algebraic expression of an sequence, and the algebraic expression of an sequence is xn, which is equals to n cube minus 6n squared plus 13n minus 7. That's your sequence. That's your algebraic expression. And what's the algebraic expression? N cube minus 2n squared plus 13n minus 7. That's the algebraic expression of this sequence. Now here the xn is so and so. I need to prove whether this is a sequence or not, whether this will come as a sequence or not. Now if the xn, instead of xn, if I put as x1, I'll replace all n as 1, right? Then here x1 is equals to, you can find out, is 1 cube minus 6 into 1 square plus 13 into 1 minus 7, plus 13 into 1 minus 7. And the answer you get when you simplify this, you get as 1. Right? Now let me put as x2 in for the n, I replace it as 2. Then that becomes 2 cube minus 6 into 2 square plus 13 into 2 minus 7. Here I get in a sequence an answer of 3. That is, what we do is we find n cube, that is 2 cube is 8 minus 6 into 2 square. 2 square is 6 minus 2 square. So that will become 6 into 2 square. The 2 square is 4. So 6 into 4 is 24. And then you have minus 13 to 2. That becomes 26 minus 7. when I calculate, when I plus or minus the whole term, the answer I get is 3. The third term, if I take it x as 3 instead of n, here I get is 3 cube minus 6 into 3 square plus 13 into 3 minus 7. Again, my answer over here is 5. If I calculate the whole thing, my answer, what I get is the 5. And the last, if I take x4 instead of n, if I take x4, and if I follow in the same procedure, in the same calculation way, my x value turns out to be 13. I find it with 13. This 13 will become, I get a sequence of 1, 3, 5, and 13. The difference between 1, 3, 5, and 13, is the common difference the same? Is what I need to understand. 1, 3, 5, and 13. Is the common difference the same? The common difference between 1, 3, and 5 is same. But between 5 and 13, the difference is different. We have a different difference. So that in that case, the sequence of 1, 3, 5, and 30 is not a sequence. It's not an arithmetic sequence. This is how we are able to understand it. That is, that sequence algebraic expression given to us was not under a sequence. The algebraic expression generated by an arithmetic sequence is not under a sequence. This is how you need to prove. If you get any sum in this factor, in this property, these are two major things which I find it was difficult for you all to solve it. That's the reason why I'm doing it over here. The rest between 1, 2, and 3, and 4 is a very common sums. I believe you all can do it on your own. Just look into it, find out what formula you need to put in to find out xm or xn or x1 or x or the cd or the d. All those things you can keep finding out by using the formula. I hope you are able to understand it, and you can go ahead. In case you have any doubts, please let me know, because this is the first step as far as sequence is concerned. The next in the terms and position is the next which I'll be taking in the next class. I hope you all have understood it, and we can take it up. In case you have any difficulty, please let me know. We will clear it up. Okay. Thank you, and we'll see you then very soon next time. Thank you very much. Bye.